right. Can you guys hear me in the back? Also, before you guys get too settled in, let me just adjust my font size to try to get something that works for us. Can you guys see this text? This text here. If you cannot see this text, there's not much more I can do because at some point I'm going to zoom in so far that I don't know, I've never tried zooming in this far. Oh, I guess this kind of works. Does that work? Oops. Hopefully this doesn't happen actually during today's lecture. Does that actually work? The only con here is that I can only show 2 lines of code at a time. But if you can't see it at 400% zoom level for me, I blame partially the screen that we have. But you might also want to consider moving up closer to the front today because I will be working mostly in code, and you will want to see what I'm typing here because otherwise you'll be bored for 3/4 of the lecture today. So if you're in the back and you can't see this text clearly, you should really consider moving to the front. If you want to do so now, I think it's a better idea than doing so in the middle of lecture when everyone's already typing away at their computers. All right, let's get started. Good morning and welcome back to Data 100, lecture number 2. Today we're going to be talking about pandas. While yesterday was a mostly conceptual overview of data science and maybe a bit of probability, today's lecture will be very practical and it'll involve a lot of coding, a lot of Python, and hopefully it'll give you a good foundation, a good conceptual foundation for you to learn the rest of pandas during lab and for the rest of this week because I've kind of elongated the lectures that we have on pandas. In the regular semester, you only have 1 lecture on pandas, but then you have multiple days of lab or discussion or so to really get your hands dirty with it. And in the summer, what I've done instead to make up for that lost time is to try to elongate these lectures a little bit so you guys can get a little more practice. Because pandas is really kind of the foundation for everything else in this class. If you can't work with data in this class, you're going to have a bad time. So hope you get a lot out of it. Okay, got some announcements. We're going to have a live lecture Piazza thread, which essentially means that on Piazza, it'll be a thread called lecture 2 questions or something like that. And if you have questions and you don't want to ask me during class, you can post on that thread. And Leo's in the back here. If you wave your hand, Leo. Everyone see Leo? He'll be managing that thread. He's one of my TAs. And you and other students can help answer each other's questions. There are no dumb questions, but in case I'm moving too fast and you miss something or you miss a detail, you can ask a question there. Okay. So you may have noticed that the screen is really small, and we have a big screen in the back, but it's broken. And so they're actually kicking us out of this room. And so starting tomorrow, we're going to be in Northgate Hall, which is a little bit that way. It's near Euclid and what's that street? Euclid and Hearst, I believe. It's near the north entrance to Berkeley. It's the School of Journalism. Please try to locate it so you can find your way there tomorrow morning at 9:30. We will not be here, so if you come here at 9:30 and find the room strangely empty, we're in Northgate, room 105. Everyone will get attendance credit for today's lecture because of this fiasco, but we're going to start collecting attendance tomorrow using a Google form. Okay, my exam conflict form link was broken, and now I have a better one that should be fixed. This one is due Friday at midnight. And this is essentially if you cannot make it to either the midterm or the final because of a class conflict, please fill out that form. We have an alternate final time. If you can't make that final time, we have a section in the form for you to put that information down, and we'll try to schedule you at a time that works for you. And we'll just try to make it work for everyone. That's kind of the goal here. Okay, we do have office hours scheduled today for homework 1. They're happening from 11 to 12, which is right after lecture, and 2 to 4 p.m. in 355 Evans. The room will change after this week. We're kind of using my office for today's office hours, but in the future it'll be in one of the classrooms, either on the 3rd or 4th floor of Evans, I believe. We have small group tutoring that's coming next week. What that means is we have 2 tutors for this class, and they will open up probably 1 hour sections where you and maybe 3 other students will meet together for a bit of time. And they'll go over some more conceptual material. They can help you with your homework. Essentially, it's a way for you to get some more guided help outside of going to office hours. Because during office hours, it's kind of you just raise your hand and ask questions. But in a small group tutoring session, the tutors will kind of reach out to you and kind of figure out, try to understand where you're at, what you're having trouble with, and those will be starting next week. So keep an eye out for that if you're interested and would like some more help for a particular week in the class. Okay, I did not do a good job of asking for names. Let me say this one thing and then get your question. I did not do a good job of asking for names yesterday. I will try to do it. I will try to enforce this a little more today. And also, please add your preferred pronouns. So if you're answering a question, just say Sam, he, him. And my question is, what's the difference between a series and a data frame? And just do that so I can try to remember your names. Okay, yes, question. Name and pronouns. So Eva, is that right? Eva, your question was, are the office hours every day or just today? Just today. But the times will probably stay the same. The room will change. But this is just, we're still working out the office hour schedule with statistics department. But today we're scheduling these office hours, especially just for homework 1, because it's due today and people would like some help. Good question, Eva. Okay. Any questions about announcements? All right. Let's get into it. We're going to be talking about Pandas today. Pandas is the Python library that we use to do data manipulation. In Data 8, you talked about the data science library that uses this class called table. And the table class in Data 8 is actually based off the Pandas data frame. But because the Pandas data frame is very complicated, we simplified the interface in Data 8 so that you can focus more on the manipulation rather than the details of the Pandas syntax. But since you're in Data 100, you're grown up now. So we're going to lay it on you today. And it'll be, I think by the end of today's lecture, you'll understand why we decided to simplify things in Data 8. Because it's complicated, it's kind of inconsistent, the documentation isn't very good, but this library is battle tested. It's used all over the world by pretty much everyone who uses Python for data science. It's one of the older libraries for Python. It's super fast. It has lots of methods for pretty much for most things that you could imagine or want to do. And so it's kind of like the power tool. But unfortunately, it's quite complicated. So what I'm trying to do today is try to give you a conceptual overview of how to think about Pandas data frames and how to think about Pandas series. And I'm going to move fast because in lecture is just not a great way to teach coding. I do have to teach it during lecture because I do want to give you a conceptual high-level overview. But you're really going to learn most of this stuff by working on problems during lab, by debugging Pandas issues. I will try to point out the nastiest ones today so that you won't have to deal with super nasty bugs when you work on your assignments. But do keep in mind that the purpose of today and tomorrow's lecture is mostly to give you a conceptual overview and not so much, you shouldn't worry too much about the syntax if the syntax was really confusing. What you should try to take away from these lectures is what's possible to do with Pandas. Okay, so you should be able to say, oh, I seem to remember Sam did something like that, And that way you can look up what you need to do when the time comes to actually work on problems. Okay, now I will move fast, but if you want me to slow down, do raise your hand and ask me some questions. If I notice a lot of questions, I will slow down and try to go through things that are difficult or challenging. I'm happy to let some of the material today slide over to the next lecture because the more important thing for me is that you feel comfortable with what we're presenting today in class. As I mentioned before, it's really important. It's the foundation for everything else you'll do in the course from now on, pretty much. So do slow me down. But if no one raises their hand and asks questions, I will zoom through the material. Okay, so be prepared. Okay. All right. So in Pandas, we work mostly with these data structures called data frames. Data frames are two-dimensional tables of data, and a series in Pandas is a one-dimensional column or a row of data. Now, in Data 8, we work with data tables, where every column has a label. Pandas works mostly the same way, except that every column and every row has a label. And the labels for rows go into what we call the index for Pandas. Okay, so on the left here, I have a data frame. You'll see that this data frame has the presidential candidates for the past few elections, and there are 5 columns in this data frame. Each of those columns has a label: candidate, party, percent, year, and result. And every row of this data frame also has a label: 0, 1, 2, 3, 4, 5, so on and so forth. Okay, so this index, what we call the index, what I highlighted in the red box on the left here, is not a column of your data frame. It is the labels for the rows of your data frame. Okay, so this actual data frame does not contain a column containing like 0, 1, 2, 3, 4, 5. These are just the labels. Okay, so you really have to make that clear. In Jupyter notebooks, they will bold that index column on the left. I should get a laser for it. But they will bold this, okay, to let you know that this is not a column. A series in Pandas looks like this. So if you're seeing this when you work on your assignments or work on Pandas problems, you should say, it's not like a pretty like sans serif font bolded thing like in HTML. It's like this monospace code looking thing, and that should signal to you that you're working with a series. Now, a series is a one-dimensional container for data. Okay, so a data frame is two-dimensional. It has columns and rows. A series is one-dimensional. It's like a list of data or an array of data. Similar to the data frame, the series also has an index, and the index here is just referring to the labels of the entries in the series. It is not a two-dimensional. It is not a two-dimensional thing. Okay, so it's not 2 columns. It's only 1 column of data, and every item in the series has a label. Okay, so you really have to make that clear. Are there any questions about this? Yes, Eva.
What kind of advantages would a series have over a data frame?
Yeah, so what kind of advantages would a series have over a data frame? There are no real advantages. Basically, sometimes you'll work with columns of data, and sometimes you'll work with tables of data. You'll see more about that when we get there. But usually we'll be working with we'll be working with the table, and then we'll extract out a column, do some stuff on the column, and then put that column back into the table. You'll see that workflow quite a bit today. All right, great question. Cool stuff. Now, we can think of a data frame as a collection of series. All right, so every column in this data frame we can think of as one series, and we kind of stack those series together to make a data frame. I have a note here from Josh Hugg, one of the previous instructors of this class. The plural of series is series. Sorry for your non-native English speakers. The plural of data frame is data frames, and the plural of index is indices. Okay, I apologize. Okay, one more thing is that the labels in the index do not necessarily have to be numbers. So you'll most often see like 0, 1, 2, 3, 4, 5, and so on, but they don't have to be numbers. They're really just labels. So for example, in this data frame here, the index for this series is Alabama, Alaska, Arizona, Arkansas, and California, so on and so forth. They're really just labels. You shouldn't think of them as only numbers. Okay. The labels in a series do not have to be unique, but the labels for a column do. I'll show you more about this really quick. I'm going to get to my demo, and then I think I'll show you hands-on what this looks like. Yes, question. Name and pronouns.
My name is Danny, and my pronouns are like series. Question about the index. Is there like a default index if we don't specify, like we have the states previously, does it just automatically go into numeric?
Yeah, so Danny asked if we don't specify the index, is that right? What happens to it? It'll be automatically numbered from 0, 1, 2, 3, 4, and so on. Yep. All right. Column labels have to be unique, but you know what? I'm just going to show you. I'm going to show you in code what this means. And so for today's lecture, I think most of the content will happen in a Jupyter notebook, and we'll be using the slides. I won't go through every single slide because there's a lot of slides. I made the slides more as a reference for you as opposed to like what we're going to do like for the full lecture. And so what we'll do today is you can follow along by going to the course website, going over here to Demo on Data Hub, and if you click that, you should be able to get to a blank notebook that looks a lot like the one that I have. So once you click that, and then it kind of runs this thing, It'll like sync the repository, and you should end up with a notebook that looks like this. Okay, so it should start off with this. Don't be too concerned about following along with everything. You can just think of it as like a way to take some quick notes about things I'm doing in class. If a snippet of code looks simple enough for you to type in, you can go ahead and type it in yourself and see what happens. But if you fall behind, don't worry too much. My goal today is, again, to like kind of get you through the ideas of what I'm doing. Yeah, name and question? Peyton says, oh, 404 not found. Oh, I also got a 404 not found. I wonder why that's happening. Let's take a look. That's because I never pushed a notebook. Okay, lecture 2. Live fix. All right, live fix. Here it comes. Let's try this again. Okay, so I think now, if you click this link, let's see here. We're going to cross our fingers. Oh my gosh, what's going on? This is tragic. Oh my goodness. Did I mess up this link? I see, Oh, I see, I did mess up this link. All right, what you want to do here is go to, so once you get to the 404 not found, you're going to take off the last part of that URL. You should get to a folder that says lec on it, so it should look like this. If you click on lec02, click on lec02-live, and that should do the trick. I deeply apologize. Okay, so if your neighbor looks confused, you can try to help them out a little bit. Again, you're going to go to, what you can do is actually go back to data100.datahub.berkeley.edu, go to summer Su19, go to lec02, and then lec02-live. That's the notebook that I'm typing in today. For reference, actually, I put the completed notebook in lec02.ipynb, so if you want to see the completed version of today's lecture notebook, you can open that. If you don't want spoilers, you can follow along in lec02-live. All right. A little snafu, but I think we're up and running. Let's get moving. So, scroll past this text. You'll see these imports at the top of most notebooks. What they do is they import the libraries that we use. We actually won't be using like matplotlib and Seaborn, although I use them so often that I just kind of include them in my imports anyway. But you will see NumPy, import NumPy as NP and import Pandas as PD. And that essentially means like import these libraries, but alias them or give them a nickname so that I don't have to type in pandas.dataframe. I can do pd.dataframe. You don't have to name this PD. You can name this like Sam is cool, for example. But if you do that, you won't be able to copy and paste code off Stack Overflow, so I suggest using PD. Okay, run that. And we'll see here that this cell here says elections.pd.readcsv. This file is a CSV file that lives in the same directory as my notebook. Oh my gosh, overwrite. And so when I run this cell, what Pandas does is it will read the CSV file and load it into a Pandas data frame. Okay, so I have here that data frame. If I want to look at characteristics of this data frame, I can type elections.shape. I can see here this data frame has 23 rows and 5 columns, so we see that also in the cell above. I can do elections.size, which is essentially how many cells this data frame has. So it's 23 times 5. And if I do elections.describe, these are just some like quick shortcuts when you get a data frame to kind of get a sense of what's happening in this data. We'll see here that this data frame got kind of cut off, but if all the rows displayed, I've kind of truncated the rows for today's lecture. So this describe method takes the columns, the numeric columns of the data frame, and computes some summary statistics over them. So here we see the average year is 1996.87. The standard deviation of the year is 11.63. There are 23 year entries in my data frame. It's essentially like a pretty cheap and fast way to get a quick sense of what's going on. It's something you can do. It's something that I normally do when I open up a data frame. Okay, now elections is this data frame. Another very common method you'll see is elections.head. Elections.head, the .head method of a data frame, takes off the first 5 rows and just shows them to you like this. So there's the first 5 rows here, Reagan, Carter, Anderson, etc. .tail does the same thing, except for the bottom rows. So it'll take the last 5 rows of the data frame. Also very useful because Pandas by default displays to you like 30 rows or something, and so your screen just gets flooded with like tables. If you do .head, the output will be a little bit more manageable and perhaps a little bit easier to read. Okay, now as you can see, let me put back up the elections table. We have here 5 columns. We have here 23 rows, and every column has a label, and every row has a label. We can change the index for this data frame by using a method called setIndex. Oops, I'm getting ahead of myself. I have one more thing to show you. So I can also change the index by using an option in pd.readcsv. So I will take this code up here, copy that, move it down to this cell. Okay. And what I can do now is add an option here. So if I type an index call equals year, now the year becomes the index of this data frame. And so the year forms the labels for the data frame's rows. Okay, so that's how we change the index. Another way to change the index is to undo this. Let elections be the same. But we can also do something like, let's say elections party index equals elections.setIndex party. Okay, and what this does is it creates a new data frame, copy that, with the index party instead of the 0, 1, 2, 3, 4 that were the defaults. Okay, now I have here a super pro tip. My super pro tip is that Jupyter Notebook has pretty nice tab completion. All right, so by tab completion, I mean you can do this. If I type in pd.read and then press tab, so I'm going to press tab now, you'll see here a list of methods that I can use. Now it's cut off because I'm zoomed into like 500%, but if you do it on your computer, you should see here a list of methods. If I keep typing in, the list of methods will shorten. And now once I find the method that I want to use, I can use my arrow keys to select it, press enter, and now I have that method there. Now, if I forget how to use this method, I can use Google to search up the documentation for it, or I can pull up the documentation directly within the notebook by typing question mark, like so. And now I see here this documentation. It's very long. There's like tons of options for this method. I'm still scrolling. Okay, there we go. There's the end. Now, the documentation for Pandas is difficult to use at times, but usually what you want to do is scroll all the way down to the bottom. Here we go. And usually most of them will have an example section. So for this example section, that's usually the most helpful thing to look at when it comes to documentation for Pandas, because some methods have like a bajillion options, and you usually want like the most commonly used. You usually want to use like the most commonly used options. Okay. Another thing you can do, another pro tip, is if you're typing stuff in line and you forget the option, or you forget the command here, you can do shift. So I'm holding shift on my keyboard and I'm pressing tab, and this pulls up inline documentation. Okay, so super fancy stuff. It just pulls it up right here, and if I wasn't zoomed in, I could see more. But if I press shift tab, if I hold shift and press tab multiple times, this documentation will expand. Okay, so it'll do it right here while I'm typing. And if I keep pressing shift tab, it'll open up on the bottom here. So I can close that. I have it on the bottom, or I can have it in line. Okay, so cool stuff. Yeah, it'll help you save some time, especially because there's a lot of methods and we often forget how to use them. Okay, so again, Shift tab, use tab completion. Those are all your friends. Okay, cool stuff. All right, so the next thing to note is, it's here. Okay, the next thing to note is that most methods in Pandas don't change your original data frame. Okay, so this gets a lot of students all the time. It will confuse you too, unless you have the right mental model for what's happening here. So when I type in elections.setIndex year, let's say, and I do that, it appears like the elections table changed. It looks like the year column became the index, but in reality, it did not change the original elections table. So if I delete this code and run this cell again, elections is still the same as it was before. I did not change the original elections. Now, if I want to actually change the original elections, most Pandas methods come with an option called in place. Now, if I type in place and then press tab, it will autocomplete the argument for me, and I can change that to true. If I change that argument to true, nothing shows up, but when I look at the elections table again, now it's changed. Okay, so most methods in Pandas don't change the original, so that means that if you do something like this, so this is what I see all the time. Let me reset my table. Let's run cell. Okay, let me reset my table. This is what I see all the time. So if I see this, if you do this, year, and then you look at elections, it will look like your code didn't work, okay? And the fact of the matter is your code did work. It's just that running the first line creates a new data frame that doesn't get saved anywhere. It doesn't change the original data frame. And so what it looks like happens is you try to set the index to year, but nothing happens. And so year is still a column in the original table. What you need to do instead is either elections equals elections.setIndex year. So that will create a new data frame and then save it to the elections name. Or you change the in place argument here and do in place equals true. And that will do what you want to do. Okay, cool stuff. I'll leave that here. Do I already have one? I do have one. Okay, leave it here. All right, any questions about this? Okay. Now, what I want to do is show you the bracket operator. Okay, so I have elections. Oftentimes, I want to do stuff on one column of elections. The way I select a column in Pandas is by using the bracket operator, which essentially means brackets, and then I pass in the name of the column I would like to take out. In this case, I will take candidate. One nice thing about the autocomplete here is if I type in can and then press tab, it will also autocomplete the column name, which is highly convenient. And if I run that, I have here the series containing the data in the column candidate from my original data frame. Okay. Now, if I select out multiple columns, so here's my elections table, I can also pass in a list of strings. If I want to take out multiple columns of this table, I can pass in a list of strings, and this will give me a data frame containing the first two columns of this original data frame. Okay, so before it has 5 columns, when I run the cell, it's going to create a new data frame or a slice of a data frame with only the first 2 columns. Let's take a look, and there you have it. So that's how you select out subsets of a data frame using columns. All right. Now, confusingly enough, every time you give a list to this bracket operator, so here's the way you should read this, by the way. So we have here the bracket operator, and the thing that goes inside is a thing. And this thing can either be a single string, in which case I will get a series, or it can be a list of strings, in which case I will get a data frame. Okay? So even if I only have a single string in my list, because it's a list, Pandas wants to give me a data frame back. Okay, like so. All right, so a single string is a series. All right, a list is always a data frame, but the list can contain multiple columns. Okay, so the behavior changes dramatically depending on what you do inside those brackets. You do want to be careful here and know that if I put double brackets, it's not like a special double bracket thing. The inside brackets correspond to a list, and the outside brackets correspond to the bracket operator. Confusing, but do keep it in mind, because you'll see this syntax all the time. Okay, now, if I pass in, now the bracket operator does one more thing, which is it slices out rows of the data frame. If I pass in a slice, 0 through 3, I will get out the first 3 rows of that data frame. All right? So the bracket operator slices out columns if you give it a string or a list of strings. It slices out rows if you give it a slice object. Now, here's where it gets real confusing. Okay, so if I type in 0, it will not give me the first row of the data frame. It will give me an error. Okay, so you might see this, and if you see key error, look how long this error message is. Okay, so like this is why people have trouble with Pandas. Right here, this is it. I'm still scrolling. Oh, here it is. Okay, so it doesn't help you at all. Like it just says key error 0, and you're just lost. So if you see key error, that means that you aren't using the bracket operator properly. The reason why you aren't using the bracket operator properly this time is that whenever you give elections a single thing, it thinks that you're getting a column. Okay, so it's trying to find the column with the label 0. There is no such column in my data frame, and thus it gives me a key error, which means that it did not find the column, or did not find the row if I'm trying to get a row. If I do 0:2, it's perfectly happy, because when it sees a slice, it thinks, let's get some rows. Okay, so you have 3 options. You have a string, which gets a series. You have a list of strings, gets a data frame. Or you have a slice, or numeric slice, which gives you a set of rows. All right. So to try to, I will give you a quiz question to try to see whether you understood all of that. So here we go. I'm going to run through these slides, but these slides just essentially recap what I just explained. Blah, blah, blah. Okay. All right, here's a question for you. If I type in the top 2 lines of code, I have a data frame, and the first column in this data frame has a label number 1, and the second column in this data frame has a label string 1, and I have like top dog, top cat, bot dog, and bot cat. Okay? Now, to try to predict the output of weird bracket 1, okay, weird bracket string 1, weird bracket 1 colon. All right, talk about it with neighbor. 2 minutes. Go ahead. All right. Any takers for the first line of code here? Weird bracket on number 1. Sorry. Who sent that? Hey, what's your name?
Rodrigo, I think it'll error.
Rodrigo, you think it'll error? Okay, well, we can try it out. But before we do that, why do you think it'll error?
Okay, so like you said, when you're giving it one thing, right, which in this case is the number 1, it's going to be expecting a string or a list of strings that like represents a column.
Okay, so it's going to error out because it's expecting a string. It turns out that it will not error out. And the reason why it doesn't error out is because there actually is a column with the label number 1. Okay, so this data frame has 2 columns. One column is labeled number 1. Another column is labeled quote 1, which is a string 1. Okay, so these 2 things in Python are actually different types. Okay, so the number 1 in Python is different from the string that contains 1. And so when I type in weird bracket number 1, I will get out the column corresponding to the number 1. Okay, so Pandas is actually pretty happy with both strings and numbers as your labels, but you will get some weird results if you do something like this. So don't do this in real life. I'm just trying to show you. I'm just trying to like get you to think a little bit about what's happening here. Okay, so number 1. All right. So what about quote 1? Quote 1 will give me the second column in this data frame, right? So number 1 gives me top dog and bot dog in a series, all right? The quote 1 will give me top cat and bot cat in a series. Now, if I do brackets around this quote 1, I will get top cat and bot cat in a data frame. Okay. My last question was, what about, so that's the second question here. My last question was about, what about 1 colon? Anyone have any guesses for what happens when I do 1 colon? Yes, name.
Reese.
Reese. Hi, Reese.
You will get the first row and anything after that.
So Reese thinks that we will get the first row and anything after that. So you're saying top dog, top cat, and bot dog, bot cat.
I'm at first index row.
So the row with index 1, which is bot dog and bot cat. And that's it. Okay, let's try it out. Excellent. Nice work, Reese. All right, so in Python, the number 1 here, in the slice, the number 1 says go from the row indexed 1 and onward. Okay, so indexes start at 0, or slices start at 0 in Python. So this will give me back the whole data frame. And if I increase this 0 to 1, this says get me everything from row 1 and onward. So if I had 5 rows in this data frame here, this syntax 1 colon will give me bot dog, bot cat, and all the rows afterward. Okay, cool stuff. Any questions about that? Yeah, name?
Oh, Julie.
Hi, Julie.
How do you select only 1 row?
Yeah, so Julie asked, how do you select only 1 row? You mean in a series or in a data frame?
Data frame.
In a data frame, to select 1 row, I can do 1 colon 2. And that will give me only the rows. So in Python, slices typically have the left end inclusive and the right end exclusive. So if I do 1 colon 2, I will get out only that row with index 1. If there were more rows in my original data frame, I would still only select out that row right there. Great question, Julie. Yes, Rodrigo.
Is there a way to get a specific element in a data frame?
Is there a way to get a specific element in a data frame? What a great question. I'll show you how to do that real soon. Okay, but rest assured you can do it all. In Pandas, the answer to most things is yes, you can do it. It's just a matter of how much pain you're willing to go through in order to make it happen. Okay, so we've looked at slicing out a data frame using columns. We've looked at slicing a data frame using the row labels. And now we can slice out data frames using the values of things inside the data frame. Okay, so the way we do that is with this thing called Boolean array selection. All right, so here we go. Don't be scared. All right, so here's my elections table. It contains these rows. Now, the bracket operator takes in yet another type of argument, a list of Boolean values, okay? So if I give the elections bracket operator a list of Boolean values, it will give me back only the rows where the value was true. So this means that it will skip the first row, skip the second row, skip the third row, fourth, fifth, sixth, seventh, eighth, and it will give me the 8th row, skip the 9th row, okay, skip the 10th row, and give me the 11th row. You kind of get the picture. So what will happen when I run this? I will only get out 4 rows corresponding to where my list was true. Okay, now this looks really dumb. Like why would you ever do that? And the reason why we do that is because when you take out a series from a data frame, let me take out elections again, and I grab out the result column. So let's suppose that I would like to get the data frame where I get only the candidates that won the election. Okay, so that means that I want to keep the results of this. I want to keep the values in this column only if the value is win, but not if the value is loss. All right, so this is a very common operation to do. I'm not slicing by the labels. I'm slicing by the values inside the data frame, and that should tip you off that you need to use something like Boolean array like slicing, okay, or filtering. Okay, so if I grab out the results column, you should try to predict with me the type of thing you're going to get out. I will get out a series. Okay, the series will contain strings. It's a series, and in Pandas, also confusingly, when you have a series containing strings, it will say the D type is an object most of the time. Most of the time, you can just think of an object as strings. Weird. Don't know why. Don't know exactly why I did that, but that's the way it is. Okay, so in Pandas, save that water bottle. It looks dirty though. Hopefully it wasn't damaged. Okay. A series in Pandas behaves like a NumPy array. Okay. So let me to just illustrate that to you. I'm going to grab out the percent column. Percent, and I have here a series containing some numbers. Like in NumPy, I can do arithmetic on this array or on the series, and it will apply this operation to every element inside of my series, which means the first element will be 55.7, second element will be 46, the third element will be 11.6, so on and so forth. Okay, so before, after. Okay? So basically, if you find yourself writing a for loop in Pandas, you're probably doing something wrong. In Pandas and in NumPy, writing a for loop is roughly 10 times as slow as doing things like using some operations on series or some built-in method on Pandas. So oftentimes you can, what I suggest to people is that if you find yourself having to do something complicated and you really cannot find any other way than writing a for loop, just write the for loop, just bite the bullet. But do try to figure out if there's a faster way to do it, because a for loop gets really, really slow as your data get pretty large. In the past lecture, we saw a table with 2 million rows. Writing a for loop on that takes a while. So an order of magnitude of 10 is something like going from a 1-minute operation to a 10-minute operation. Okay, so that's the difference between I don't know, taking a sip of water and going to a walk, going around the park for a walk. Okay, so you do want to try to use what we call these vectorized operations wherever we can. By vectorized, we mean they apply to everything inside of a collection of elements. Okay, so results. Like in NumPy, I can do Boolean operations on a series. When I write this, it will compare every element of my series to my right-hand side, the string win. And it will give me back a Boolean series, which contains true or false only if the element inside was the same as the right-hand side, which means that the first row will be true, or the first element of my new series will be true, second element will be false, third element will be false. All right, let's watch and see. Okay, so now we can see that we have a series containing trues and falses. And I can save this series to a variable. And now I can do elections, bracket is win. So now we see why it's useful to have the ability to put in a collection of booleans into this bracket operator here. The first line says, give me a series where every element is true only if the equality here it holds. And the second line says, okay, now slice out only the rows in my data frame where the series was true. And thus, I get out only the rows of the data frame where the result was win. Okay, so this is the canonical or standard way of filtering out values from a data frame filtering out rows of a data frame according to the value inside of a particular cell. You'll see this a lot, and what you'll see even more often is this. They won't even use this here, they'll just paste that right in, and you'll see this. It looks really complicated, but do keep in mind that this right here is a Boolean series, okay? And everything else is a bracket slicing operator. Bam. Okay, so I have here only the candidates that won the elections from the years 1980 to 2016. All right. Now we can combine Boolean series. Now we can combine Boolean filtering. For example, what if I want only the, let's see here. Okay, I'm going to move this down. Do that. Okay. I have here some text that I was supposed to put my code in, but I did not follow that. In my final version of this notebook, the code does go with where the text is supposed to be, so you can ignore this text for now. Okay. Now, elections. Okay. So what if I want to find the candidates that won the election but lost a popular vote, okay, or got less than half of the popular vote, 50%? In order to do that, I need to filter on two conditions, right? I want to look at the win of the result column as well as the value of the percent column, and only select out the rows where both the result is win and the percent is less than 50. In order to do that, I can chain Boolean expressions together. So first I can do elections results, result equals win, and elections percent is less than 50. Okay, so here's another gotcha, okay? The first gotcha is if you want to AND together some Boolean series, you have to use the ampersand. You cannot use the Python keyword AND. Don't ask me why, that's what they did. And if you want to use an OR, right, you can't write the Python OR, you have to use what's called the pipe. The reason for these operators is because they work on bitwise expressions if you've taken 61C or some other similar class. But for our purposes, if that sounds like magic to you, it pretty much is magic. Just remember that if you're trying to conjunct or AND or OR together some Boolean series, you need to use the ampersand or the pipe operators. The second gotcha, and this gets everybody, is you need parentheses around both expressions here. Okay, you need the parentheses around this, and you need parentheses around this. If I have more expressions here, let's say I want candidate. Let's see, I do that, and I want the candidate to be, I don't know, candidate, Reagan. I still need the parentheses around every single expression that I have here. Okay, so weird syntax, but okay. And you have to really just remember that you need parentheses. If you don't put parentheses, this is what happens. I'll show you the error message so you can try to debug it yourself. All right, you get a crazy error, okay, and you see this bitwise AND not supported for the input types, and the inputs cannot be safely coerced to it. This is arcane. I won't expect you to know any of this. And then there's during the handling of the above expression, another exception occurred. Yeah. So if you see this kind of thing, usually that means check your parentheses. Okay. If you try to use the Python keyword AND, you will also get a value error. The value error of a series is ambiguous. Okay. The value of a series is ambiguous usually means you did this instead of this. Okay. So these errors are very hard to debug unless you have some insider knowledge. I'm trying to give you that insider knowledge today. Cool stuff. Yes, Daniel?
Yeah. If you want, instead of and, if you want to use or, you also have to use offering.
That's right. You have to use the pipe operator here. You cannot use the Python or. That will also give you a value error. Okay, so pipe and ampersand. Remember those. Okay. All right, ready to amp it up even more? All right, let's do this. So, we've talked now about the bracket operator, and now we're going to talk about another form of the bracket operator called loc and iloc. Let me advance my slides a little bit here. So we've gone through the Boolean array, gone through Jackie Chan, who's confused, but now he's not confused because he understands that this is what you need Boolean arrays for. Now we're going to move on to loc and iloc. Okay. Now, loc and iloc are essentially longhand versions of the original bracket notation. So when I do bracket candidate, like so, this will give me back, again, the series containing the candidates and strings. Now, .loc will give me, this is shorthand, okay? So this right here produces the same results as .loc string candidate. To convince you, I will run these two lines of code. So the first one gives me a series. The second line also gives me a series. They do the same thing. This is a longer version of the first one. And the reason why we have this longer version is because I can also use loc to slice out some rows at the same time. Okay, so what you should remember for loc is the first thing that goes here in loc is the row selector. The second thing that goes here for loc is the column selector. Okay, so I have here thing 1, I have here thing 2. Thing 1 refers to a label for a row. Let's say I want to get out Anderson, right? I had a question earlier from Rodrigo about how I can get a single value. Oh, sorry. Rodrigo, your name is Luis. I apologize. Luis, about how I can get a single value from the data frame. This is how you do it, okay? I want to get out the value where the row label is 2 and the column label is candidate. And .loc will allow me to do that, like so. So now I have here just the Python string candidate. Okay. Now, as with the bracket notation that I introduced earlier, I can change either of these to a list of things. Okay, so here is where things get pretty hairy, so try to follow along. 0, 1, 2, 3. And I'm going to change this to candidate, party, and year. So what happened here? I got back the data frame containing candidate, party, and year columns, and the rows with labels 0, 1, 2, and 3. If I delete the 1 here, I get back just a data frame with 0, 2, and 3, like so. Okay? So again, remember that .loc takes in two things, okay? It takes in two things. The first thing has to be the selector for the rows. The second thing has to be the selector for the columns. All right? Now this right here, now what you see is very rare that people will actually name these things different variables. You'll just see this. Okay, so if you see this, just know that it's using .loc. This is the much more common syntax that you'll see in the real world. And this is what people will do. It looks confusing. It is confusing. But you have to learn it because that's what people do, sadly enough. Okay. Now, let me add another layer onto you. I can slice in loc. I can slice between strings in loc. This gives me back the rows with labels 0 through 3 and the columns with labels candidate through year inclusive on the right endpoint, okay? So in loc, when I slice, the right endpoint is included. Year is included in this final table. So is the row 3 in this numeric slice here. Because .loc works on labels, it does not work on numeric indexes, okay? So the right endpoint is always included with loc when you're using a slice. It is highly confusing, I understand. That's why I'm telling it to you now, so you won't be surprised and confused when it happens to you in real life. Okay. Now, let's see here. Okay, so now let me show you a few more variants of what you might notice in real life. So let me do 0 through 5. Let me do candidate. This gives me the first 5 candidates of my data frame. Confusingly enough, this is equivalent to this following bit of code here. Okay, so why are these two equivalent? Let me just show you again. Result of the first line, let me delete this, is the result of the second line is identical. And yet they look somewhat different. What's happening here? Yes, Danny.
The first block of code, the first indices before is included when you're slicing. The fourth element, the fourth row is included. And you're specifying the column name candidate. The second block of code, the first thing you're doing is actually getting the candidate column. And then once you have that frame, the data frame, you're actually slicing, and the fifth element, the fifth row is not included.
Yes, great. So, when you're using brackets by themselves without .loc, numeric slices are right exclusive. So that means that the row with label 5 or row with index 5 is not included. When you're using .loc, the slices are always right inclusive. So the row with label 4 is included, but not the label 5. Okay. Yeah. So imagine teaching this to like people who've never learned Python before. Okay. So this is why we use data. This is why we use a tables library. Okay. So let me go back to this. If I give this a list, as you might expect, I get a data frame. Just like how for the brackets, when I give it a list instead of a single string, I always get back a data frame, even if that list only contains a single string. If I change the slice to be a single label for a row, let me do, okay, so if I do loc with 2 colons, I get back the whole data frame, because the 2 colons mean, a colon without a left or right endpoint just means grab everything. This means grab all the rows. This means grab all the columns. If I change this to 1, I get back an interesting series. Okay, so let me do that again for you. I'm going to change this first colon to 1. What that means is it'll look down the index of my data frame, look for the row with label 1, grab out all the columns for that row, and put the values into a series, but that series contains the values of a row and not of a column. Okay, so again, the series is a one-dimensional slice of a data frame. Sometimes we'll slice out a column, that's the more common case, but other times we'll slice out a row, and this is how you slice out a row. By specifying the row label in .loc, and by asking for the columns you want as a second argument to .loc. So this will give you back the series containing Carter, Democratic, 41.0, 1980, and the string loss. The series will contain a special index. The index of that series will be the label of the columns here. And let me show you what that looks like. Okay, so again, I'm going to run this code now. Carter, Democratic, 41, 1980, and loss. The labels, the index of the series are the column labels of my original data frame. Okay. As with columns, if I give this guy a list, I get back, what do you think? I get back a data frame, okay, containing 1 row. All right. So the way you should think about this is, let me just show you elections again. Okay. I have here a 2-dimensional table of data, right? I can slice out any number of columns and any number of rows. But if I only slice out 1 column, I get back a series, because a series is 1-dimensional. If I slice out only 1 column and only 1 row, I get back a single value, a single cell, because that only corresponds to 1 value in my data frame. If I slice out multiple columns and multiple rows, I get back a data frame. And so the way we specify whether we want one or many is via using either a slice or a list. So you see here, a slice means get many columns. A single value here gets one row. So that'll give me a series. If I change this to be a list, now I'm telling Pandas, give me many rows and give me many columns. That means Pandas will always give you back a data frame. Okay. Any questions about this? Done my best here. Okay, now let me continue onward. Now the reason why, or the most common reason you'll see iloc being used in the real world is for using Boolean array slicing and column selection at the same time. Okay, so I have this, and let's suppose that I want to get back the candidates that won the election but did not get 50% of the popular vote, and I can scroll back up here to grab this Boolean expression. I can throw this into my row selection place in elections, and as my second thing in election, in .loc, oops, .loc here, move that over, okay. And as my second thing here, I will pass in the columns candidate and party. So this gives me back only the candidates that won the election, the candidate and the party of the people that won the election but lost the popular vote. Okay. So again, you can do this without using .loc, right? So as before, I did something like that, and I can put this in, and this will give me back all the rows that only correspond to the candidate winning the election but losing the popular vote. And then I can do another set of brackets here, just like that, columns. So these two things are shorthands for each other. It just looks complicated. And so sometimes we'll use .loc depending on what you fancy. I might do something like that. Okay. Those two will do this. These two lines will do the same thing. They both look very confusing. I understand. But you'll get used to it, hopefully with enough time. Okay. I'm going to talk to you briefly about iloc. So I'm going to skip all this text. All right, so do that. Okay, one more pro tip here is if you have a variable that you want to use, you can tab complete the variable too. Elect, and then I press tab, and that will give me back a list of variables that are defined. I can press enter to select that. It helps avoid typos and just saves some time overall. So basically just tab everything, and sometimes you'll get good stuff. Okay. If I use .loc, .loc works on labels of columns and labels of rows. .iloc works on indices of columns and indices of rows. So if I ask for all the rows, I can also select out the first and the second and the third columns of my data frame by using iloc. Okay, so this works pretty similar to in Python when you're working with lists and you do like list bracket 2. It selects the element at position 2 in the list. In Pandas, instead of using that list-like syntax, we use .iloc. Okay. I can pass in slices here, but here's a tricky thing about slices. Okay, you ready for this? Slices in loc are inclusive. Slices in iloc are exclusive. So I have here a data frame that has the rows 0 through 2, and the columns 0, 1, 2, and 3, but not the column 4, and not the row 3. Okay? There are just tons of gotchas. Be prepared. Okay. Sometimes iloc is more convenient. So if you have like really nasty column names, like if your CSV has really nasty column names, I've had like files where like a column name was like a sentence or whatever. Like that's really nasty to type in for loc. In that case, it is sometimes more convenient to use iloc. But oftentimes we kind of shy away from using iloc because it's a little bit harder to use and it's not as clear what you're trying to do. So for example, if someone goes into your CSV and messes around with the order of your columns, and you're using .iloc, your code will just break, okay? But if you're using .loc, your code will still work because you're selecting out the columns using their labels, not based on their position in your data frame or in your file. Okay, but it is convenient sometimes. It is convenient. Okay, let me advance my slides here. Okay, documentation here. Loc accesses labels. iloc selects my position. Okay, I did want to show you this because the bracket syntax that I started off the lecture with is you can think of like a shorthand for using .loc and .iloc. Okay, so the first block here I have is elections bracket candidate .head 6. The second line of code here is the equivalent line using .loc. So the line at the top essentially says grab all the rows, but only the candidate column. And the last line here in this first block is kind of what the shorthand is, what the shorthand expands out to in the underlying Pandas code. Similarly, when I do elections bracket the list candidate here, this is equivalent to writing .loc, but passing it a list as the column selector. And when I use the index, the slice operation, the slice object here for elections, using just a bracket, this expands to .iloc, 0 to 3. You'll notice that this row here does not, this data frame here does not contain the row at index 3. So the endpoint here is right exclusive, and it corresponds to using .iloc here, 0 to 3. Okay, so a lot of ways to slice and dice a data frame. I just try to give you a taste of like the main methods today. It's kind of dry, and there are a lot of gotchas and a lot of like really weird nuances that have to go with these. But we go through this during lecture because in the real world, people used iloc and .iloc all the time. Like I don't think there's been a single data science project I have not used at least like one of these. Okay, so they're always used for almost every single project that you'll ever work on. It pays off to know them well, so you don't have to like deal with all the syntax issues and all the bugs down the road. Okay. All right, let's take a 5-minute break. Okay, I can't take 5 minutes. I can only take 2. All right, our 2-minute break is over. I have some more slides here with properties and utility functions for data frames. I'm not going to go through them. I have gone through a few, but you can look through them and play around with them yourself. I don't really want to show you all of them like one by one. I do want to point out the sort values method, which actually turned out to be really, really useful. So when you do sort values, you give it a column name, and when you run this code here, it'll give you back a new data frame where the values in that column are sorted, and the values of the rows move along with the columns. Okay? So if I put ascending equals false here, I can sort in descending order. So this right here, this line of code here sorts by the candidates that received the most popular votes in ascending order. Okay, so I have here Reagan, who was really popular, and then Bush, who was also pretty popular, Obama, and Reagan, and then it'll keep going down until I get to the last person. Okay. A lot of methods on data frames also happen to work on series, not all the time, but most of the time. Okay, so you can actually use .loc and .iloc on series. Similarly, you can use .sort values on series. Usually you can just like try it out and pray that it works, and most of the time it'll work out okay. If not, you have to find like the series specific method. Okay. There is one, yes, Dan.
The default ascending is true, right?
The default ascending is true, yes. If you took data 8, you may remember that in tables, the argument is like descending equals true and ascending equals false. I'm sorry, that was our fault. Okay. There is one series-specific method that is useful to know called value counts. It essentially just counts up the number of times every value in a series occurs. So in this case, if I do elections party, I grab out the series containing all the political parties and the candidates. And if I do value counts on that series, I get back a series containing the number of times each party appeared. The party is the index of the series, and the values of this series are integers. Okay, so it's pretty niche, but actually is used quite a bit, which is why I mentioned it here. And it's an example of a series-only method. You can't do this on a data frame, you can only do this on a series. All right, skip that. All right, so let me go through a quick study because we've gone through like a lot of just details about methods. I wanted to end by showing you that you can do something actually decently useful with what you've learned today. And by something useful, I can show you that using what we learned today, you can find out the most popular name in California last year. So let's do that now. Okay, I'm gonna scroll down here, scroll down. All right. This bit of code downloads the data set, but also does not it'll download the data set, but if the data set already exists, it won't download it again. Pretty useful stuff. I won't go through the details here. This line of code here sets up a zip file reader, so you don't have to unzip a zip file. Okay, so the first bit of code downloads this big old zip file containing the Social Security data set I looked at yesterday. This bit of code here uses the zip file package in Python to essentially work with the zip file without extracting it. It's pretty useful to know this stuff for future reference because sometimes you get like this huge zip file, you don't want to re-download it every time. Sometimes that huge zip file will be even huger when you unzip it, and so you don't actually want to unzip it, you just want to work with the zip file as is. And so this stuff is useful to know. Okay, I won't go through the details of this, but I will go through, I will use the zip file stuff to get out the names of babies born in California from the Social Security data set, okay? So here I have the California data frame. It contains 374,000 rows. We can see here the baby names and the years as we looked at yesterday. And I'm gonna skip all of this, go down to the bottom here. So, in order to find out the names that were the most popular in California last year, I want to first make sure that my data frame only contains the values corresponding to last year, which is 2018. After I do that, I can then sort by the count in descending order. And that will give me a data frame containing the list of names in descending order of popularity. Okay, so usually it's a good idea to kind of plan out your attack before you go typing away on Pandas. The reason why I say it's a good idea is because the first time you do these things, you'll make a lot of syntax mistakes. And if you make a lot of syntax mistakes, you'll lose track of your plan, and when you lose track of your plan, you lose track of your analysis and your life, maybe. Hopefully not. Okay, so I made my plan, which is filter rows for only 2018. Second step of my plan, sort descending count. Okay, so I had that down. I can first look at my California data frame, grab out only the rows where the year is 2018, like so. Oops. There should be a number. Okay. I can slice out the rows corresponding to that year, and there's no rows. I wonder what happened. Oh, I see. It's a little old. I can only do 2017. Bummer. I didn't re-download it. Okay, 2017 then. I can save this into a variable, like so. And what you'll see me do during lecture, and what you should also do during when you work on your actual assignments, is write a bit of code and then try it out. Don't write the whole thing at once, because when you write a lot of code and then it errors out, you have no idea where the error happened. It could be anywhere. And there are many places for errors to happen when it comes to Pandas. Write it out, write as small snippets of code as you possibly can. That'll just help you avoid a lot of debugging issues, because at least you'll know where the error is happening. Okay, sort values. Let me run this. Okay, so now I have here only the rows containing the year 2017. I can sort values. It's not auto-completing, sadly. Count. This gives me the counts in ascending order, not descending order. So I can do Shift-Tab to look for the argument that I want. If I forget the name of it, right? So I can do ascending equals true. And I can change this true to false. And I see here that last year, the most popular names in California were Emma, Mia, and Noah. The least popular names are Mary Grace, wow, Matilda, and Zim. All right, I'll see you tomorrow.